Hey there guys, here we're going through AQA's June 2018 Foundation GCSE Maths Paper 2, which is the first calculator paper. I'll put links to paper 1 and 3 down below, as well as some of the useful bits and bobs, including formulas you need, secret calculator tricks, and topic playlists to help with this paper. Let's do this. Question 1 wants us to circle the expression that is the same as 2y. So, it's the guy on the left, it's y plus y. Y squared is y times y. 2 plus y is 2 plus y. And then again on the right, y times y is y squared. Question 2 wants us to circle the decimal between 3/10 and 2/5. So, using your calculator, we can turn each of these into decimals. So 3/10 is 0.3, 2/5 is 0.4. So we need a number between those two. And again, it's the guy on our left, 0.32. Question 3. What is 625 as a power of 5? So again, we can stick these in our calculators and see which of them gives us 625. So 5 cubed means 5 times 5 times 5, which is 125. So it's not that. 5 times 4 though, 5 times 5 times 5 times 5 does give us 625. Question 4. What is the order of rotational symmetry of this drawing? So, rotational symmetry, or the order of rotational symmetry, means how many times, if we spin this drawing at full 360 degrees, how many times would it look exactly the same as this? So we can count there are like 8 triangles around the outside. So through a 360 degree spin, it's going to look exactly the same 8 times. So the order is 8. Question 5 wants us to work out 3 to the 6th minus the square root of 841. Use your calculators. 3 to the 6th is 729. Square root of 841 is 29. So 729 minus 29 is 700. Question 6. Gemma has 4 groups of friends on a social media site. The table shows the number of people in each group. Part A asks us which group is the mode. So the mode is the most common, so the one with the highest frequency. So we can see here that is school with 26. Okay, then for part B, Gemma wants to draw a pictogram to show this information. She's done the first 2 rows. We want to complete the pictogram and remember to complete the key. So, the first 2 rows have both got 2 circles. Now, in the first 2 groups, family and netball, there are 8 people in both groups. So that means then that 2 circles represent 8 people. So 1 circle represents 4 people. So there's the key. Okay, now for school, there are 26 people. So 1 circle is 4, 8, 12, 16, 20, 24. Now we need 2 more people to get to 26. So that is half of a circle, which maybe I would draw like that, just to make sure it's easy to see it's half a circle. And then, for guides, there are 11 people. So, 2 whole circles is 8. Now we need 3 more. So that's going to be 3/4 of a circle. Cool. In the 7th, E is 3 more than D, F is 5 less than D. Part A wants us to write an expression for E in terms of D. So that means we want to write E equals something to do with D. So, if E is 3 more than D, then E is D plus 3. Part B wants us to write an expression for F in terms of D. So, F is 5 less than D. So, F is D minus 5. Then part C wants us to work out E minus F, simplifying our answer. So, E minus F is D plus 3 minus D minus 5. Now we need to be really careful here with our minus signs. So I put the expression for F in brackets here because both parts get affected by the negative sign. So we got D plus 3 minus D, and then minus 5. So that is plus 5. So we're left with D minus D, so they cancel out, and then 3 plus 5 is 8. Question 8. The numbers 1 to 12 are in a grid, so some of the numbers are already in there. We're told each side of the grid must add up to 26, and we want to complete the grid using the numbers 1, 3, 6, 8, 9 and 11. So, first thing to look for is, does any side of the grid have only one square missing? Yes, it does, and that is the top left side. So 12 add 4 add 7 is equal to 23. So for this left hand side to add up to 26, we're going to need to put 3 in the top left. So let's cross them out as we go. Okay, now the top side has only one side missing, one square missing, sorry. So 3 add 5 add 10 is 18. So to get to 26, we need another 8. So we're going to put 8 in there. Okay, now the right hand side has 3 missing numbers. The bottom side only has 2 missing numbers. So 7 add 2 is equal to 9. 26 minus 9 is equal to 17. So these two numbers on the bottom now need to add up to 17. So the only way that we can get 17 is with 11 and 6. Now, we also need to be a bit clever here, because we need to think, well, is the 11 going to go in the first empty square, or is it going to go down in the bottom corner and also be a part of the right line? So the two numbers that we're going to be left with are 9 and 1. So that means that 9 and 1 have to go there. So now 10 add 9 add 1 is 20. So that means 6 is going to go there and 11 goes there. To 9, so in this question we are using 1 foot is 12 inches and 1 inch is 2.5 centimetres. We want to turn 5 feet 8 inches into centimetres. So 5 feet is 5 times 12 inches, which is 60 inches. So 5 foot 8 inches is 68 inches. So to turn that into centimetres, we're going to do 68 times 2.5, which is going to give us 170 centimetres. Cool. Question 10 asks which of these numbers has exactly 4 factors. So factors are numbers that divide a bigger number exactly. So 4 has 1, 2 and 4. So 8 has 1 and 8, 2 and 4. Boom. So we'll do the others as well. 12 has 1, 12, 2, 6, 3, 4. And 16 has 1, 16, 2, 8, 4 and 4. Cool. Okay, question 11. Nick has a 6-digit code. He remembers it as 3 2-digit numbers. The first number is between 10 and 20. The second number is 3 times the first number. And the third number is 5 times the first number. All the digits are different. We want to work out the code. So, let's put first, second, third, and have a go. Okay, so the first number between 10 and 20 is 11. So, if we try 11, well, straight away we got a problem because we're told all the digits are different. Here we got 2 ones. So, nope. Okay, then we'll try 12. So the second number is 3 times the first, which is 36. And then the third number is 5 times the first number. And that's going to give us 60. So that's not it, because 6 has repeated. So, nope. 13. 3 times 13 is 39. Now 3 is repeated. Nope. 14. 3 times 14 is 42. 4 has repeated. So, nope. 15. 3 times 15 is 45. 5 has repeated. 16. 3 times 16 is 48. So that's alright up to there. 5 times 16 is 80. So the 8 has repeated. So, nope. 17. 3 times 17 is 51. 5 times 17 is 85. 5 is repeated, so no. 18, maybe. Okay, 3 times 18 is 54. And 5 times 18 is 90. So there we go. No digits have repeated. That is our winner. Okay, so we got 1, 8, 5, 4, 9, 0. Cool. Question 12 asks us how many minutes are there in 5 1/4 hours. Okay. 1 hour is 60 minutes, so 5 hours is 300, and then 1/4 of an hour is 15 minutes. Add them together, it's 315, which is there. Cool. Okay, question 13. So we're given a formula for the amount of water needed to cook rice. So W is 1.5 R and 0.5, where W is the number of cups of water and R is the number of cups of rice. So part A asks us how many cups of water are needed to cook 7 cups of rice. So here R is equal to 7. So W is 1.5 times 7 add 0.5. 1.5 times 7 is 10.5. So add 0.5 and we get 11. Use your calculators, remember. Part B. How many cups of rice can be cooked with 20 cups of water? So here we're going, well, W is equal to 20. So 20 is equal to 1.5 R, add 0.5. So we now want to solve this for R. So first thing we're going to do is subtract 0.5. So we're going to get 19.5 is equal to 1.5 R, and then we divide by 1.5 and we get, so 19.5 divided by 1.5 is 13. So we can cook 13 cups of rice. Okay, question 14 wants us to use our calculator to work out 9.95 squared times 29.8. So that's exactly what I've done. You want to write down everything on your calculator display. So hopefully you should get the same as me. Part B asks us, is our answer to part A sensible? Use approximation to check. So when we're using approximation, we are making the numbers nicer, and we're going to do it with our calculator. So we're going to round 9.95 to 10 and 29.8 to 30. So we're going to say 9.95 squared times 29.8 is approximately equal to 10 squared times 30. So this is 100 times 30, which is 3,000. So when it says, is our answer sensible, it means we don't get a massive difference, like thousands different. So 2,950 is, on the grand scale of things, quite close to 3,000. So yes, it is sensible. Question 15. The graph of y equals 4 minus x is drawn on a grid for us from x between -2 to 5. We want to draw the graph of y equals 2x minus 5 for values of x from -2 to 5. So we want y equals 2x minus 5. The easiest way to draw a graph is to find some coordinates. So I'm going to box out a little coordinate table. Now I'm going to use values of x 0, 1 and 2. To draw a straight line you only really need 2 points, but if you use 3 points it's a good way to check that you are right, because the 3 points will lie on a straight line. If one of them doesn't, something has gone wrong. If we only use 2 points, there's no way of knowing if it's right or wrong. So, when x is equal to 2, y when x is equal to 0, y is 2 times 0 minus 5. So that's minus 5. When x is 1, y is 2 times 1, which is 2, minus 5, which is minus 3. And when x is 2, 2 times 2 is 4, minus 5 is minus 1. So now we have 3 pairs of coordinates that we can plot. So I've already done my line. 0 minus 5 is the first red point, and then 1 minus 3 is the second, and then 2 minus 1 is the third. So something to look out for here is they've used different scales on the x and the y axis. So be careful to look out for things like that. So if you've got your 3 points plotted, draw the straight line going all the way through from minus 5 up to 2. Okay, and then part B wants us to use our graph to solve 2x minus 5 is equal to 4 minus x. So the way that we use a graph to do this is look for the point where the graphs meet. So the graphs meet here, and the value of x is 3. So that is the answer. Okay, for 16a we got some missing angle fun. So BCD is a straight line, ABC is an equilateral triangle, and CE is equal to DE. We want to find the size of angle X. So, what do we know? Well, we know that this triangle on the right is an isosceles triangle because it has 2 side lengths the same. So that means this angle here is the same as this angle here. Now, angles in a triangle add up to 180. So if we do 180 minus 28, we get 152. So each of these blue angles at the bottom are going to be half of 152. So 152 divided by 2 is 76 degrees. So we now know this angle is 76 degrees. Now we know that this 76 degree angle, X, and the third angle on the left are angles on a straight line, so they add to 180. So what would be really handy now is if we could work out this angle, which we can. Remember, ABC is equilateral. That means all the angles inside are the same size. So, this angle is going to be 180 divided by 3, which is 60. So, now we know 2 of the 3 angles on this straight line. So we know that X add 60 add 76 is equal to 180. So X add 136 is equal to 180. So x is equal to 44 degrees. Okay, then for part B, Amber is working out the size of an interior angle of a regular octagon. Her method is to do 360 divided by 8. Is her method correct? We must give a reason for our answer. So, her method is not correct. The reason is the sum of interior angles increases with the number of sides and is not 360 for octagons. She would be right if she was working out the size of an exterior angle. Exterior angles always add up to 360. Interior angles, though, do not. As I just said, the sum gets bigger with the number of sides the shape has. But what she has done is worked out the size of an exterior angle. So because it's good practice, I've decided to put a little bit extra on this question. So first of all, an exterior angle is the angle made between if one side of the shape carried on and the next side of the shape. So that is an exterior angle. Now with an octagon, this would be 360 divided by 8. So 360 divided by 8 is 45. So the exterior angle of this octagon is 45. Now from that, she could have worked out the interior angle because interior and exterior angles are on a straight line. So to work out the interior angle here, she could have then done 180 minus 45, which would give her 135. 17, we got a map of an island with a scale of 1 centimetre represents 200 kilometres. So we got cities A, B and C. We're told that A is due west of B. We want to write down the bearing of A from B. So with bearings, we got north, east, south, west. North is always 0 degrees, east is 90, south is 180, and west is 270. So that's our answer. Then for part B, we're told Umar drives from A to B on the route shown. Kaz drives from B to C on the route shown. We want to use the map to work out how much further Umar drove than Kaz. So, we need to use the scale on the map. So, if this was printed out, we would find the length of A to B is 6.5 centimetres. Now remember, the scale is hiding. It's 1 centimetre represents 200 kilometres. So, A to B is 6.5 times 200. So, that is going to give us 1,300 kilometres. So that is how far Umar drove. Now cars altogether, driving from B to C, drove, well, in terms of centimetres, 2.7 centimetres and 2 centimetres. So B to C is, well, 2 add 2.7 is 4.7 centimetres. So it's going to be 4.7 times 200. Which is going to give us 940 kilometres. Now remember, we want to know how much further Umar drove than cars. So we now do 1,300 kilometres minus 940, and that is going to give us 360 kilometres. In 18, a shop sells raincoats and umbrellas. We got a scatter diagram showing information about the sales over 12 months. So we got sales of umbrellas along the bottom, sales of raincoats going up the side. Part A asks us to write down the type of correlation shown. So we can see as the sale of umbrellas increases, so do the sales of raincoats. We're going up from left to right. So this is positive correlation. Cool. Okay, and then for part B, the manager expects the sales of umbrellas to next month to be £60. We want to use a line of best fit to estimate the sales of raincoats. Okay, so if we draw a line of best fit, could be a little bit better maybe, say something like that. So as long as the line fits quite tightly with the data, then we're golden. So the point of drawing a line of best fit is that we can now find our £60 for our sales of umbrellas, which is here. We go up until we hit our line of best fit, which is here, and then we're going to go across to our raincoat sales. It's going to take us to about there. So now we need to work out the scale. So 5 little squares gets us from 125 to 150. So every little square is worth £5. So this is going to be £130. And you might get a slightly different answer because you'll have a different line of best fit. And 19 wants us to work out x lots of x minus 4. So we're expanding this bracket, so x times x is x squared, and x times minus 4 gives us minus 4x. So x squared minus 4x is our guy. Question 20 tells us A to B is 5 to 2. How many times larger is A than B? Give your answer. So, if A and B are in the ratio 5 to 2, we could think of A as being 5 and B being 2. We want to know how many times larger A is than B. So if we do 5 divided by 2, we get 2.5. Okay, question 21. A circle has radius 4.2 centimeters. We want to work out the circumference to 1 decimal place. So, circumference is pi times diameter, and the diameter is 2 times the radius. So 2 times 4.2 is 8.4 centimeters. So the circumference is 8.4 pi, which is going to give us 26.389 blah blah blah. So that rounded to 1 decimal place is 26.4 centimeters. Okay, and then part B, we got a circle, centre O, and it wants us to draw a sector. So a sector looks like that. It's like a slice of pizza. 2 ordinary fair dice are rolled, and we want to complete this tree diagram. So, in the tree diagram, the 2 outcomes we're interested in is that the dice is less than 3 or 3 or more. Now remember, probability always has to add up to 1. So the probability of less than 3 is a third. The probability of 3 or more is 2/3. Now the probabilities are exactly the same for the second dice. So that is our completed tree diagram. And then part B wants us to work out the probability that both dice land on a number less than 3. So, on the tree diagram, the root that we want is less than 3 and then less than 3. So when you're going along a tree diagram like that, we multiply the probabilities together. So this is 1/3 times 1/3, which gives us 1/9. Okay, 23, we want to match up each sequence to its description. So the first one's been done for us. 1, 1, 2, 3, 5 is a Fibonacci sequence. We are adding the 2 previous terms to get the next term. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, etc. So that is a Fibonacci sequence. With this second one, 1, 2, 4, 8, 16, 32, to get from term to term, we are multiplying by 2. So this type of sequence is called a geometric sequence, or progression, same thing. Next one down, 1, 2, 3, 4, 5, 6. So here, we are adding 1 each time. So a sequence where you add the same amount to each term is called arithmetic. So this guy is an arithmetic progression. Okay, now the next one down may not look familiar to us, so in that instance, move on, and I hope that we can use the process of elimination. Hopefully the next one looks familiar, 1, 4, 9, 16, 25, 36, and they are our square numbers. And then the very bottom one, 1, 8, 27, etc. These guys are our cube numbers. 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, etc. So those are our cubes, which means this guy up here is our triangular numbers. Now the reason that we call these guys triangular numbers is doesn't work very well with a 1. But say we have 3 dots, we can arrange them in a triangle like that. With 6, we can do the same. So that is why these guys are called triangular numbers. Okay, so the table shows information about the population of a city. So we got the population in 2001 and 2011. Liam claims from 2011 to 2021, the population will increase by the same percentage as from 2001 to 2011. He works out the population increase from 2001 to 2011 is 480,000 minus 420,000, which is 60,000. Then he works out the population in 2021 will be 480,000 add 60,000, which is going to give us 540,000. Does the population of 540,000 match his claim? So, what we can see from his workings here is that he has done nothing to do with percentages. He's worked out the actual amount that the population increased from 2001 to 2011, and then he's just added on the same amount. So, what we're going to do is work out, first of all, what percentage that increase was. So the percentage increase from 2001 to 2011 is, well, the actual increase was 60,000. And then we would divide that by the original population in 2001. So 420,000. And that is roughly going to give us 0.14, rounded to 2 decimal places. So then 0.14 times 100 is 14%. So from 2001 to 2011, there was a 14% population increase. Now let's work out by his claim by his claim of 540,000 in 2021, and then the increase from 2011 to 2021 would be 60,000 over 480,000. Now as a decimal, that is 0.125. As a percentage, 0.125 times 100 is 12.5%. So by his claim, we don't have the same percentage increase. So the answer is no. 5 on 3 days, Ali throws darts at a target. We got his results in the table. We are asking part A to work out 2 different probabilities for the probability of Ali hitting the target. So we're going to use relative frequency here. So let's go on Monday. He hit the target 15 times out of 20. So that's one of them. And then on Tuesday, he hit the target 22 times out of 30. So there's another one. Cool. Okay, then part B says which of our 2 estimates is the better estimation for the probability of Ali hitting the target. So it's 22 out of 30. The reason being, he threw the darts more times in total. So the more times you do something, the more accurate your results are. So if he threw the darts 100 times, we'd get even better results and a better estimation for the probability. Okay, question 26. So Theo has savings of £18, James has savings of £0. He has no savings. Each week from now, Theo will save £4.50 and James will save £4. We want to work out in how many weeks Theo and James will have savings in the ratio 15 to 8. Okay, so at the start, Theo to James is 18 to 0. Now we know from this ratio down here, we want James's savings to be a multiple of 8. So instead of adding £4.50 and £4 to Theo and James every 1 week, we're going to go up in every 2 weeks. So every 2 weeks, Theo is going to save 2 times £4.50, which is £9. Theo saves £9, and James saves 2 times 4, which is 8. Okay, so after 2 weeks, then, Theo has saved another £9, so he's going to have 27, and James is going to have saved 8. So we can't simplify that ratio at all, so we'll go another 2 weeks. So that's now going to be 4 weeks later. So Theo is going to have another £9, which is 36. James will have another 8, so he will have 16. Now this ratio does simplify. There is a common factor there of 4, so that would simplify down to 9 to 4. Now that is not 15 to 8, so that's no good. So we go another 2 weeks on, so that's now going to be 6 weeks. So James will have another £9. Sorry, Theo will have another £9. So he's now going to have 45. James is going to have another £8. So he's going to have 24. Now this has a common factor of 3. So this does simplify to 15 to 8, which is what we wanted. So that took 6 weeks. Question 27, so we're given the volume of a sphere is 4/3 pi r cubed, where r is the radius. We've got a container, which is a hemisphere of radius 30 centimetres. Now a hemisphere is exactly half of a sphere. Now we're told sound fills the container at a rate of 4,000 centimetres cubed per minute, and we are asked, does it take less than a quarter of an hour to fill the container? So we're going to need to work out the volume of the container and then work out how many lots of 4,000 centimetres cubed are in that, and that's going to tell us how many minutes it takes to fill the container. So the volume of a hemisphere is going to be half the volume of a sphere. So if the volume of a sphere is 4/3 pi r cubed, then the volume of a hemisphere is 2/3 pi r cubed. So the volume of our container here, so I'm going to go at just volume, that's going to be 2/3 times pi times 30 cubed. Now if we put that in our calculator, hopefully you will get 18,000 pi centimeters cubed. So that is the volume of the container. Now we're told sand fills the container at 4,000 centimeters cubed per minute. So we want to work out how many lots of 4,000 centimeters cubed there are in 18,000 centimeters cubed, and that will tell us how many minutes it takes to fill the container. So 18,000 pi divided by 4,000. If we go to 2 decimal places, we get 14.14. So it takes 14.14 minutes to fill the container. Quarter of an hour is 15 minutes. The question asked, does it take less than a quarter of an hour? So the answer is yes. Okay, final question, and we got some error intervals. So this is one of my most watched videos. I'll put a link down below. So basically, whenever you do any sort of rounding, you make an error. An error interval is the range of values the actual number could have been in before we did the rounding. So here, a regular pentagon, or each side of a regular pentagon, is 8.4 centimeters to 1 decimal place. We want to complete the error interval for the length of each side. So the lower bound is the smallest number that would round up to 8.4 to 1 decimal place. So that would be 8.35, and the upper bound is the smallest number that wouldn't round down to 8.4. So that is going to be 8.45. And then part B wants us to complete the error interval for the perimeter. So we know two things about this shape. It's irregular, so all the side lengths are the same, and it's a pentagon, so a pentagon has 5 sides. So all that we do is multiply each of the bounds of the side length error interval by 5. So 5 times 8.35 is 41.75, and 5 times 8.45 is 42.25. So there it is, guys, paper done. Really hope you found this useful. Don't forget to give us a thumbs up, get subscribed, share with your friends, because they might need some help too. Thanks a lot for watching. Take it easy, take care.